Hi, this is Mr. Ward, and I'm going to do a short video on the discriminant, which is a part of the quadratic formula which you can use to help you distinguish or discriminate or predict, really predicting, you're using it to predict what kind of parabola do we have? How does it relate to the x-axis? So you could have a quadratic. I'll give some examples here. You could have a quadratic y equals x squared minus 5x plus, we'll say plus 4. And that's going to have two x-intercepts. You can see it goes to the x-axis twice. We can also have another one. So there's examples where we're going to have y equals x squared plus 6x plus 9. And that only touches the x-axis once. Okay, that happens to be a perfect square there. But I could also have another one where it's y equals x squared plus 6x, x squared plus 6x plus 11. Okay, now that one doesn't ever go through the x-axis. So it has roots, it has solutions, but its solutions are going to have to step outside the so-called real number system. We would have to use what are called complex imaginary numbers, and I'm going to explain why. So let's take a look at each one of these. The part of the quadratic formula, which is called the discriminant, it's the same in the plus or minus version. It's the part that's under the square root. And the reason it's really useful is if you're getting a square root of a positive number, you're going to get a plus or minus square root. If you're getting a square root of a negative number, you're going to get a plus or minus square root, but they have to work around the problem that you can't get a square root of a negative number in the so-called real number system. You have to go out to a different number system that was developed to deal with this, called the complex imaginary system. And there's a whole world of analysis of that has huge implications for the real world. So don't for a second think that those are actually imaginary. They are real stuff that we deal with. There's another possibility that b squared minus 4ac could be 0. If it's 0, we're going to get the square root of 0, and there's no plus or minus 0. You're just going to eliminate the square root, and all that will be left is negative b over 2a. So let's see how we can work with this. So b squared minus 4ac. So b squared minus 4ac. The first thing you want to do is identify what a, b, and c are. Okay, this is in standard form. If it was not in standard form, you'd want to organize it into standard form. So you'd have the square term, then the linear term. That's the one that has just an x to the first. And then the constant term would be in that order, in what's called descending order. You'd have combined all like terms, and now we can set up the a, b, and c. So a in this case is 1. B is negative 5, and C is 4. Okay, so let's deal with that. So B is negative 5, and since it's negative and I'm squaring it, I'm putting the negative inside parentheses. Okay, and then A is 1, and C is this last standalone term. C is 4. Okay. Now Desmos is telling us that equals 9, and that's a very convenient thing. That's the second thing a discriminant will tell us. Since I get 9 for the discriminant, that's a neat and tidy perfect square. We'll be getting the square root of that. It'll be a plus or minus 3. And if you have a neat and tidy square root that can come out of square root jail, the whole square root collapses into just a plus or minus 3, you're going to have a rational solution also. But we will have two solutions because it's going to be a plus or minus 3. So here's our vertex right here at 2.5, negative 2.25, and we get a plus or minus. So we're 1.5 that way and 1.5 that way. So that relates to this 3, and it'll be over a 2. So it's 3 over 2 to the right and 3 over 2 to the left. But the big idea for the discriminant is, number one, we have two solutions. Number two, since our discriminant is a neat and tidy perfect square, we also have two rational solutions. We're not dealing with irreducible radicals. Now, let's try the discriminant for the second one, which you already saw only has one x-intercept. So when I do b squared minus 4ac, I replace b with 6 because that's what b is. I replace a with 1, and I replace c with 9. Okay, so I'm going to end up with 6 squared, which is 36. Desmos has already identified that this is 0. And 4 times 1, which is 4. And 4 times 9, which is 36. I'm doing 36 minus 36. My discriminant boils down to a 0. If I plug that into the quadratic formula, which I'll do now, okay, negative b plus the square root of 0 all over 2a. And we'll replace a with 1, replace b with 6, and you end up with 6 plus or negative 6 plus or minus the square root of 0. But the square root of 0 is nothing, so there's not a plus or minus. So you're just going to get negative 6 over 2 is our solution. You could think of it as one solution used twice, or two solutions that are the same number. So negative 3 is our x-axis, and we could actually use that to factor this equation here as x plus 3, because x plus 3 means an x-intercept at negative 3, times x plus 3. And you end up with a perfect square, which I will demonstrate now. It is a perfect square to the 21st. That's an interesting thing, but we wanted just square. Okay, so the discriminant was 0, and so we only have one solution that's used twice. Okay, or should I say it's one solution used twice technically, but it's just one real solution. It touches once on the x-axis. If the discriminant was positive, we have two solutions in the so-called real number system. Now, let's take a look at the third situation where my parabola doesn't touch the x-axis at all. And so I'm going to have b squared minus 4ac, and b was 6 squared, and a is 1, and c is 11. And so what's going to happen is I'm going to do 6 squared, and that's going to be 36. Then I'm going to say 4 times 1, which is just 4, and 4 times 11, which becomes 44. So I've got 36 minus 44. I've got a negative 8, which is going to be, we're getting the square root of negative 8. And you can't get the square root of negative 8 inside the real number system. The square root of negative 8 is plus or minus the square root of 8 times I, which is the square root of negative 1. You would break negative 8 into negative 1 times 8, and we get the square root of both of those. And we can do that. It's actually doable. It's not that horrible to do. Square root of that is going to equal, and Desmos will say it's undefined, but that's going to equal the square root of 8 times the square root of negative 1. And the square root of negative 1 we depict as the letter I. And we can simplify the square root of 8 a little further because that's 4 times 2. And we can pull the 4 out of square root jail, and so it becomes 2. And we end up with plus or minus, I didn't like that, plus or minus 2 root 2 times I. And if you squared 2 root 2 times I, you would end up with negative 8. But that goes into the so-called complex imaginary system, which is an exceeding opportunity for you. But that is what it is. I hope that was helpful for you. Just the bottom line is, if the discriminant is negative, you'll have no real solutions. All right, so this will be slightly disjointed. I get interrupted, so I'm not sure exactly where I left off. But what I am saying is, if the discriminant is positive, you will have two solutions in the real number system. If the discriminant is because of the plus or minus square root, if the discriminant is positive and a neat and tidy square, those solutions will be will be rational numbers like this, and that'll be convenient. You won't have to deal with any radicals. If the discriminant is 0, then you're going to have one solution, one x-intercept, and the quadratic will look like this. If the discriminant is negative, you're going to have to go outside the real number system to get solutions, and so your parabola won't touch the x-axis. It'll be considered to have no real solutions.